For this lesson, I'm going to demonstrate graphing some piecewise functions. I'm going to graph two examples here, and then we will work with some more in class. So we looked at piecewise functions before, but that was before we did transformations. Previously, we would graph several lines as a piecewise function, and piecewise functions are broken up into pieces, obviously. The domain is split. So the first one here we're going to look at, we have x minus 2 when x is less than 0, and x squared plus 1 when x is greater than or equal to 0. So our transition point is when x is 0. If I look at the top one, this is a line equation, and let's just find out what it is at 0. I can't graph it. I'm not allowed to graph that point, but we can graph an open circle there to represent that point. So for this one, if I'm trying to find the value of that function, it's going to be 0, negative 2. So on my graph, I have a y-intercept of negative 2, but since I can't allow it at 0, it has to be an open circle. And then we're going to graph the rest of that line only to the left of the y-axis. So this is a slope of 1. We already have our y-intercept. So it's a positive slope, which means he should be pointing in the downward direction. As he moves left to right, the slope is increasing 1 over 1. Now for the right-hand side, we are going to graph the x squared function with a translation of 1 up. So if you think about your x squared function, its vertex is originally at the origin. Now I want to be 1 unit up from the origin, and there I'm going to graph, after that, I'm going to graph my parent function. The transition point is when x is 0. So here, when x is 0, I know because it is defined, f of 0 is going to be 1. That's a closed circle because I can actually define that one because of my inequality sign is greater than or equal to. Since this is the point of the x squared function shifted up by 1, I'm going to graph the second half of the parabola. You can choose a couple points if you want to, but you should know by now that to graph that parent function, it's right 1, up 1. From your new vertex, right 1, up 1, right 2, up 4. And there's the parabola. So this is a piecewise function on the left-hand side. It's a line. It's an open circle because of the less than symbol. On the right-hand side, it's a parabola shifted up by 1 unit because of the greater than or equal to and the plus 1. Alright, this one I've made slightly more complicated. We have an absolute value function with a left shift of 5 units and a square root function with a left shift of 1 unit. My transition point is negative 1. That helps this guy out because he's going to start at the negative 1. He's going to start a little bit further away. So this is still the transition point. So I'm going to find this point right here just so I have it for the graph. I'm going to evaluate f of negative 1, which means I have to evaluate it up here. F of negative 1 is going to be the absolute value of negative 1 plus 5. And that is going to be 4. So I'm going to sketch this graph, and hopefully your lines will be straighter than my lines. X and Y. And I need to put some tick marks on here because I need to go to negative 1 and negative 5. And I'll put some on the other side. Alright. So I know this is a point on the graph, negative 1, 4. And it's a point on the graph because it's less than or equal to. This symbol tells me I can actually graph that point. So negative 1, 4 is right here. There's a point on the graph. Now if you think about your transformation, this is an absolute value function. Its vertex is shifted to the left by 5. So I'm going to come over here, 1, 2, 3, 4, 5, and there's my vertex. So my left hand, my absolute value function is graphed like that. It terminates at this point that we calculated, which is the transition point for my function. The second guy it's going to be graphed from -1 on. But he has to have an open circle at -1. If I evaluated him at -1, -1 plus 1 would be 0. So that point is going to be an open circle on the graph. From my knowledge of translations and transformations, I know that the parent function is going to shift to the left by 1. So this is actually the start of my square root graph. From here, I move to the right 1 and up 1 and put a point. From my beginning again, I now move to the right 4 and up 2 and put a point. And there you have it. That's what that piecewise function looks like. I used 2 different parent functions and some translations to kind of show you what we can do with this. You just break it down in pieces. I would find the point of transition, which is whatever this value is when it's included the point, and put a closed circle there. That way you know the other one has to be an open circle. And then to the left of this guy is this function. That's why he's here. To the right of -1 is the square root function. So we're going to work more of this and do more examples in class. This gives you a really good practice again for your transformations, your parent functions, and learning how to split a domain.